so now it's one of our last topics, which is the waterfall method. Wait, let me just write it so it's cute. Waterfall slash cascade. I don't know the proper name in English, but what matters is the meaning. And the thing about it is that it is really similar to the step-by-step method. So you have the pressure lines, but instead of activating just one position, for example, A plus, B plus, and C plus, we could do it all in one line. So we could do like A, B plus, C plus, and we would activate it just through the first line and add the sensors using this first line. This method was used in the intuitive one, but I didn't go through it because I thought it wasn't necessary. But what we do here is that we combine activating different actuators on one line with the step-by-step method. So, for example, on the sequence we were working on, which is, sorry for the mess, we had all of these movements, right? So here, what we would do is to divide our sequence in some groups instead of just using different lines for each one of the movements. We can combine some of them in just one line. So that's why it's like a waterfall, because it goes through one line to the other, activating different movements at once. So what we could do for the waterfall method is that we can keep the activation on the same line as long as no letter repeats itself. What I mean is, like, A appears here and is the next letter A? No. So we can keep it on the same line. And now we have A and B. And if the next one was a C, we could keep it in our first line, but since it's a B, we need to split it. So what we do is we split, and then since we're starting another line is we see B, okay, we haven't used B in this line, C, okay, we haven't used C in this line, but then again we have a C. So we split and then we go to the next line. And this last line, we just check, okay, C and A is not C, so it can go in the same line. So basically, sorry for the mess, our rule is that you can activate different actuators in one line, but never the same one on the same line. Sorry, I read so slowly, but never the same one. So the thing is, every time we have a sequence, so A, B plus, C plus, B minus, C minus, A minus, C plus, for example, we always have to split it right after the first actuator repeats itself. So here is A, B, C, so no repetition, but then there's a B, which already was used in the first line, so we just split it. And then we have B, C, A, okay, no one repeating, and then we have C, which is a repeat of what was already used in the second line, so we just split. And it's always like this, and then we're gonna do a similar logic to move from line to line, but it's a little different. I'm gonna introduce it, but we're also gonna have a logic inside the line, because in one line we're gonna have to activate A before and then B and then C. So all the logic of sensors, for example, the A plus sensor, which is gonna be triggered, it's gonna then activate B plus. So we're gonna have the SA plus sensor, which is going to trigger the movement still on the first line, and then the SB plus sensor, which is going to trigger the C plus, and so on. So it's really similar, but it's a little different in some ways. And another thing that I'm gonna copy just so it's a little better to see. Another thing that we have here, it's a memory valve. I already explained it a little, but I think it's good to review it. So what happens here is that what you can do, okay, so these things are on the wrong place, as you can see, but I just fixed it. You can activate two lines using the same valve. And just a reminder of how is the normal valve that we are used to use, and it just activates one line and it deactivates it like this. You activate this line and then you deactivate it. But using this valve, you cannot activate this other way, right? Because we just activate the left side or deactivate also the left side. But with the memory valve, what happens is, as the name says, it holds a memory. So it can activate the first line and then it can activate the second one. And then it can move back to the position of having the first one activated or not activating anything at all. But that's what it's happening here. It basically can actuate on two different ways at the same time without needing to have two valves to activate two different outputs. And that's it. And we're gonna have a rule for the waterfall method that it is. We're gonna have the command sets, which is the way we're splitting our sequence. So for example, on this sequence, we split it in 4 command groups. So it's AB because nobody repeats itself, and then B because the next one is also B, so we have to split it, and then it's B, B again, and A. So we have 4 command groups. And the rule for that is we're always gonna have N minus 1 memory valves. And the memory valves is the valves I was just talking about, which is this. So we're gonna combine, in that case, since we have 4 groups, we're gonna combine 3 memory valves. And that's it. Now I'm gonna explain how do we do it. It is not that complicated, but it is a little tricky. But I think I'm gonna use an pre-built example because I think it's easier just to visualize, and then we're gonna build it together again. What did I do? Nothing, right? Okay. So just writing line 1 here. But what happens is basically let's just look at the way the lines are activated, and then I'm gonna go through everything that's happening here because it's a lot. But let's just pretend we pushed here and then this valve moved, and what happens is that the pressure, which is coming from here, it goes through here and it reaches here, 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 and it goes all the way up here, and then it activates the first line. Okay, and then what we can have is we're gonna have a movement that is gonna trigger for it to go to the second line. So then something happens and then it shifts this valve. Once this valve is shifted, it moves like this, and then the pressure that was coming from here, it's gonna go inside here and it's gonna come from this side instead of this one, which was the letter we were using. So then it activates the second line. Then something happens in the second line, we activate a bunch of stuff, and then something's gonna happen and we're gonna shift the second valve for the third line, which just, and then when we do that, this pressure that was coming on the midway and was leaving through here, it's gonna now come through here and leave on this side. So then it's gonna activate the third line as it was supposed to, as we intended it to happen. And then something's gonna happen again. It's gonna trigger some sensors and do some stuff, really nice stuff, and then blah, blah, and then it's gonna shift the valve which was shifted before to activate the first line, which we'll see that's making kind of sense right now, because the thing that we discussed about on the step-by-step method is that the last line is always on when we're starting, and the first movement is the one that's responsible of turning the last line off and turning the first line on. So if this valve that was shifted for the movement to start to the line 1, it's moved again to the initial position, and instead of moving the pressure through here, which was what was being done until now, it now moves the pressure until here, and this is also the initial position. And what this line does is it reaches the last line, activating the last line, and then it's going to do some sequence on the last line, and that's it. So it may seem like a lot, but it's gonna be always something like this. It's gonna look like this, and it's gonna have the number of lines, so n, which is our number of lines, minus 1 memory valves, which are this one that can activate 2 ways at a time. And then we're just gonna have our default line and our second line that it can activate. And since here it is providing for the first line, is just activate another one and then another one here. So it's basically like a cascade, because one thing happens and then it's connected to the other and connected to the other, and it keeps shifting. And another thing that it's really important for me to mention about these valves is that, I don't know if you remember, but when we were dealing with a lot of weird stuff that I drew, with the step-by-step method, we knew that the valve that activates one line was responsible for turning off the previous line. So what we can see here is that it makes sure that the previous line was on, and then it shifts this valve and it goes through here. But when it does that, it's also turning off the pressure there, because once the pressure gets to this line, it activates this side of the path and the valve moves back to this direction, and then it deactivates the other line. So you make sure that the previous line is on, and then you shift the valve to activate the next line, and the pressure on the next line, it's gonna enter back to the previous line valve, and it's gonna deactivate the previous line. So it is a little confusing saying it like this, but it's what we've been doing for the whole time, that we're gonna use the previous line to activate the next one our current line and then deactivate by the following line. Okay, so what we have here is pretty similar, because so we have our first line, our second line, which is also activated through here actually, but through our memory valve, and then it's going to be deactivated through the next one. So we activate 1, we activate 2, and then when it reaches 3, we deactivate it, moving it back to the position 1, because it's the starting position and it needs to go back to the default. So that's it for the memory valves. And now I'm gonna move it a little just so we understand what's happening. So we have the valve here, and let's just ignore all the rest of the circuit. So we're just focusing here, not on the other parts, but let's pretend we press a button here, the last line is activated, and then it goes through here and the air shifts this valve. The pressure was coming here and then activating the last line, and then now the pressure comes here because this shift. I'm not going to shift it actually, but I will be drawing in yellow. And then it goes through here. There's nothing to shift back here, so it just keeps flowing and it reaches position 1. Then it goes back, something happens, and it triggers here. Once it moves this valve, the air will now come through here and activate the second line. Once it activates the second line, the only thing it's going to do is do the second movement, because the thing is, it doesn't have to deactivate the first line using another valve and another connection on the second line to the first line, because it's doing that on this valve. So this valve, once it shifts and activates the second line, it's also turning off the first line into the atmosphere. So this is the main benefit of it. And it allows us to use less valves than we were using in the step-by-step method. Because here we use n-1, and on the step-by-step we used n. And here we are also combining the movements. So we're using even less valves, but that's for the next video. Okay, so then it will keep doing the same thing, and when it activates the second line, do the stuff it has to do on the second line, and then it's going to trigger the third line. Something happened and it's going to shift this valve. Once it shifts this valve, the air is going to go through here, and what happens is the third line has another connection. Not just the movements that it has to do on the third line, but it's connected to the previous valve. And once they receive pressure again, it's going to move this valve back to its original position. And that's it. And then it's going to happen the same thing on the next valve. Once the air reaches here, it's going to go to the fourth line, and the fourth line is also going to turn the second valve responsible for the third line into its original position. So it's always going to have this kind of scheme. And if you want to add, for example, if you have 5 lines and you want to add another one, what you would have to do is just add another valve here and do the same stuff. Connect it to the next one in the same way we were doing, but it's gonna be activated on this side, so the start would be like here. It's kind of messy, and then the initial position of the last valve would be the right one. So it's always gonna be like this. The initial position for all the valves is left one, and except for the last valve, which is the right one, because when you push the button, it moves to the left position. I hope it helped. to understand at least how the faults work. But oh, my headphones dropped. I'd hope I'm not saying it again. I'm sorry, but I hope it's listenable. But now I'm gonna go to actually how we design the circuit and what is the upper part, because there's a lot happening there also, but that's for the next video.